Okay, I'm going to quickly run you through a couple of problems that are similar to tonight's homework. The first equation that we had, or talked about today, was A equals, hold on a second. Okay, so start again here real quick. A, the amount of money you have in the bank, for example, is equal to your principal times the irrational number E to the RT. Okay, so R is our rate as a decimal, and T is our time. Okay, and so if, let's say we had $2,000, and it's going to be compounded continuously, at 4% for 10 years, we can use this equation to figure out how much money we'd have at the end of those 10 years. Let's take this and put it on a new page. And so our formula, just plugging in, it is really a plug and chug thing. You have to be a little bit careful when you throw it into your calculator. But our formula looks like this: 2,000 times e to the, here's our percent as a decimal, times our time, 10. Now it's very important we do that in parentheses, especially when we plug it into the calculator. So in our calculator we want to make sure we go 2,000, you have an e to the x button, so you're going to use that. In most calculators it shows the caret and then parentheses, 0.04 times 10, or you can just do that in your head and get 0.4. Regardless, I'm going to grab my calculator here really quick, and I go 2,000. The ln button above that is the e to the x, and then I type in 0.04 times 10 m parentheses equals, looks like at the end of 10 years you're going to have $2,983.65. We'll round it up. Okay, so that was the first type of problem that we had to do, and all the compounding interest ones work pretty much the same way. The second type of problem deals with half-life. In half-life, we talked about the fact that that is how long it takes for half of the mass of a sample to change into something else. Okay, and a formula, if you like formulas, piece it together, is going to be as follows: T over T sub half. That first T isn't very good. T, okay, and in this case A naught, or A original, is the original amount. A is just the amount we have left. T is the time it decays, and T sub half equals your half-life time. And that's a fixed value for the substance that you have. And basically what this is doing, if we look at one, let's say we have some material and its half-life is 15 days. Okay. And let's say our original amount was, we start with 50 grams of that material. And so our equation then would be A equals 50 times 1/2 to the T over 15. And so to kind of understand this, we can see it's a decay function because of the half. And this business up here in the exponent is basically a way of counting how many half-lives we've undergone. So when T, for example, is 15, we end up with 15 over 15, which is 1. So we have 1 half-life, and half of 50 then is just 25. If T is 30, we have 30 divided by 15, that's 2 half-lives. And 1/2 squared then is 1/4. and so we'd have 1/4 of 50, or 12.5 left over. So we can write this function pretty quickly if we remember this little template at the top. So quickly running you through an example, let's say we've got 50 grams of a material that decays with a half-life of 11 days. And the question is, how much material is left after, let's use 30 days. So our equation looks like this. The amount we're going to have left is equal to our original amount, and then count up how many half-lives that is by taking the time that it's been decaying divided by 11 to get our half-life number, or the number of half-lives that had occurred. So for us, after 30 days, the amount at 30 days would be equal to 50 times 1/2 to the 30 over 11. Okay. For this on your calculators, you can just go straight forward and you go 50 times, you can just do 0.5 to the, then you have to put your exponent in parentheses, 30 divided by 11 in parentheses. And it looks like we come up with 7.55 grams. We can kind of tell if this makes sense. Okay. Quickly, we'll start with our 50 grams, and after one half-life, that's 11 days, we'd be down to 25. After another half-life, that's 22 days we're up to now, we'd be down to 12.5. If we do one more half-life, that's 33 days, we'd be down to 6.25. Well, we didn't quite get a full another half-life in there. We did get past a full half-life again. We went to 33 days, we go down to 6.25 of material. At 30 days, we should have something a little bit more than that. And that's exactly what our calculation showed. We had 7.55 grams. Okay. The last part is just, I'm going to list your assignment again for those who may have missed or forgot to write it down. So the last slide, here we go. You have, for homework, page 434, 15 through 28, 30, 36, and 37. Please remember that you do get credit in part for showing what the original problem was. You don't have to write down the whole problem, but it does help to write down the given information and what you're trying to calculate, not just put down the calculation. Doesn't mean a whole lot to us.